Hello. Does it work? Perfect. So thank you so much. I wasn't expecting that many people in the last presentation. Yeah, and thank you for a great conference. It's amazing and it's quite refreshing, to be honest. So yeah, first big disclaimer: there is no Rust, there's no there's no storage in this presentation, and there's fridge outside. There's beer outside, so. Uh, I'm just saying, you still can. There's no formal verification. So, yeah. So, we are going to talk about cameras, right? I work in Google, I work in Chrome OS, and I work in the team that supports that tiny hole there. And it's a small, but it's a big headache. We have a lot of problems. So, first of all, cameras, right? We're in Axis, and you have Linux cameras, and yeah. So how do we access cameras in Linux? Yeah. So we use something called Video for Linux, just to make it yeah, just to make it simple. The standard is quite old. I was checking when it was landed, and it landed in 2002. And that is not the most fun part. The most fun part is that I've been working quite a bit on cameras, and I don't know. I think I haven't never met Gert in my life. So when this landed, there was two use cases. Yeah. um, there was two use cases for cameras. The one was to connect your brand new Logitech multimedia camera and take 640 times 480 photos, or try to watch El Clásico for free when you weren't supposed to. So Video for Linux complies. It takes it supports two kind of devices, at least two. One is cameras. The other one is DVB devices. And like everything in Linux, it's so easy to use, right? You just have a block device, a chart device, and you just read it. And in fact, you can. The problem is that as frames get bigger and bigger and resolutions get and frame rates gets bigger and bigger, you cannot do that anymore. Or you still can, but performance is not going to be the best. So yeah, it's a standard Linux device, /dev/video something for each one of your devices. But usually the API looks more or less like this. So first you open your device, then you select the format that you want to use. You do that with this IOCTL. Then you set the frame rate. Then you set some controls. That is the exposure, that is the gain. So all that kind of things you do with cameras. Then you request some buffers. You say, okay, I'm going to work with 50 frames at the same time, maximum 32, with 12 buffers at the same time. And then you enqueue them. Enqueuing them means you tell Linux, hey, this is your buffer now. I'm not going to touch it. And then you stream on. You turn on the camera, and you wait for the buffers to be ready. Depends on what is the nature of these buffers. They can be user pointers. They can be DMA buff. They can be memory mapped. You will read them in a different way. And yeah, the problem is that not all the cameras supports all the formats. Because there are many formats. So usually when you want to use Video for Linux device, you put something in the middle. So a very thin library is lib4l2, and it has some kind of CPU-based color conversion. Yeah, and it's also helped to transitioning from Video for Linux 1 to Video for Linux 2. It has an adaptation layer. But this is how it works. So basically, we still consider devices to be a black box where we get things from it. And how does it look from the driver side? So driver side, we have 122 callbacks that we can implement. And yeah, that's quite a bit of work. Luckily, we have some helpers. Right? We have 3 big things in the kernel, 3 big libraries, utilities, however you want to call it, that help us implementing some of these. So one is the video buffer 2. The other one is the control framework, which is in charge of setting and creating controls, and there's some small amount of helpers. But besides that, you still, for a very simple driver, you still have to make a lot of work. For example, the Vivid, which is the virtual video driver, it's implementing 100 of these callbacks. So, yeah. But while we were busy making video for Linux too, the manufacturers didn't sleep. They modified their hardware so it's not a black box anymore. It's a combination of black boxes. So IP cores start to become a thing, and vendors, when they make their system on chips, they pick different components, they pick different IPs from different vendors, and they put it inside their chips, so they don't have to do the implementation from scratch, which that's what you want, right? At the beginning, we were supporting every combination of blocks as one driver, but of course this doesn't scale, and we had to invent something. And what we invented was the media subsystem. So we know how to control black boxes. We are computer engineers. We are computer science. So what we do, we just copy paste the old design and implement a tree. Right, so that is basically a media subsystem. We have a tree of devices, of sub-devices that we can interconnect into each other. So, yeah, before we had one of these, now we have multiple of them. And yeah, this has some problems. The first and most important problem, in my opinion, is that the API that we have to all of this is still controls and formats. So everything is a standard, everything is well defined. So if your hardware needs to be configured, all that configuration is very well defined. It needs to be completely defined. And that is okay for some of the normal features, but today, when vendors, they have to decide where they invest their bill of materials, they realize that the most important part are cameras. Users are more willing to invest $100 more in a better camera than $100 more than in more memory. They take memory and CPU for granted, but users, they don't take the cameras for granted. So if we force vendors to say exactly how they are implementing their algorithms, how they are doing the background removal, how they are doing the HDR, they are basically leaking their IP, and they are not very happy, and they don't want to do that. And the other problem is that we assume that hardware is made in different blocks. But while we were busy implementing the media controller, they completely redesigned the way they make the transition of how they build their hardware. So remember, we started with a black box, then we moved to a combination of black boxes, but today, cameras, they look like a computer inside. They have already made the transition from something that is configurable to something that is programmable. And we cannot use an API for configurable things to something that is programmable. And what we think it works like this in blocks, in reality is implemented like this. So the manufacturer, they have programs for how to make these different components interconnect. This is just a random architecture for an ISP. And by the way, this is proprietary. Vendors, they don't want to leak how they are doing it, because then other companies can do it. And they don't want to release how are the algorithms running in these processing blocks. So it doesn't match anymore the hardware. How it looks, how we are trying to deal with this in consumer products like Chrome OS. So it's with something like this. So this is our camera stack. At the very bottom, we have video for Linux, and then we need to support different clients, different user space. And in between, we sit the camera hull. This is what is in the middle. We still allow vendors to have something proprietary on the side, and this is completely contained, and this is in completely blocked, so this cannot do anything crazy, and the interface is well defined. But in the old days, we could, this is not something standard. Every single hardware is different. So what happens when we want to implement a different type of camera, we need to have a new API. We need to have a different HAL. And when there's a vendor coming with a new product, we need to implement a new HAL. So what happens is that today in Chrome OS, we have a number of HALs, and that's a nightmare because we need to maintain. This doesn't scale. This can work for 2 or 3 devices, but as we get more and more devices, this doesn't work anymore. Leap camera can help somehow. It can help to abstract the hardware, abstract the access to these different components. But it doesn't solve the other problems. It doesn't solve how to deal with a programmable device. Leap camera still uses video for Linux. And Leap camera, the API between the secret sauce, this is what the vendor wants to keep super secret, and Leap camera needs to be completely defined. And by defining this API, you are relieving what is the hardware inside. You are leaking all your secrets, and that's not what vendors want. So you will say, I have in my pocket an amazing phone with amazing camera, and it's working fine. It has amazing features. It has everything. It's right. And Android is Linux, right? How they do it? How is this working? Well, they took a different approach. Android, they are not using video for Linux. Instead, what they do is they have defined what is this HAL. So they say cameras, they need to support a specific UAPI, which is the camera HAL 3. And on the side, they provide you a CTS. CTS is some tests that you have to run. If your HAL can pass these specific tests, then yeah, your HAL is good to go. And however you implement it, that's up to you. You can do it in user space, you can do it in hardware, you can do whatever. But yeah, this is bad, right? I mean, it's working fine. The proof is that most of you will have an Android device and it's working really good. But there's the code in this area is much less reviewed than the code in the kernel, right? Kernel, there's much more eyes to look into that. So how are we going to solve it? How can we fix this video for Linux API? Well, the proposal from Chrome OS is Kcam. Kcam is we don't want to replace video for Linux. We just want to make another subsystem on the side. Pretty much what we have been discussing with Rust is not Kcam or video for Linux. It's Kcam and video for Linux. And the proposal is pretty much like DRM. So we want to have an API where most of the work is done in user space. It's not in the kernel. We just want the kernel to do very basic stuff, which is going to be a scheduling, discovery, and there's power management missing there. And everything else is provided in user space. In Kcam, we have a tree, pretty much like in video for Linux. But here we don't define, this is not used to define how the data is moving from one device to the other. This arrow doesn't say that the data is going from here to here. This is just describing how the hardware looks like. So it's pretty much like a device tree for devices that doesn't have device tree. We have a HAL on top, which is in user space, and all the driver specific is in that area. In Kcam, we have operations. So operations are small blocks that are executed by the entities. So the tree is composed by entities, and entities execute operations. And we execute operations as fast as we can. But operations can have dependencies. What dependencies can operation have? Well, operations can depend on other operations. So you will say, when you have completed with this, do the next thing. You can also depend on sensor events. You can also depend on hardware events. Let's say when the user presses the trigger, you're going to capture a frame. You can depend on more than one thing. You can depend on 2 operations or on an operation and a hardware event. And you can also depend on user fences. So you can synchronize events happening in user space with the kernel. And you send these operations in a single IOCTL, and they are executed as fast as they can. So you are not, the number of interactions between user space and the kernel is much more limited than NVIDIA for Linux. And it's much more flexible because you define exactly what everything is doing. And it's much low level. You design the operation is defined by every single driver, pretty much like in DRM. So in DRM, every driver has its own API towards user space, and this is the same. One big difference compared to Video for Linux is that we have a single device. We have Kcam, and there's only one. We don't have Video for Linux 0, 1, 2, 3, 4, 5. And why is that? It's because we want to do tight collaborations between different devices. So that way we can do collaborative things with, for example, the lens and the sensor. We can do things with the sensor and the trigger. We can do, we can do much more advanced stuff. Especially focus is very tricky, and it works very good for things like that. And this is how an application in Kcam looks like. You open the device. First of all, you discover the hardware because you want to know which device you have. And then you just enqueue operations and wait for the operations to happen. Of course, all the operations are validated, and all the access to memory, which is buffers, is abstracted in buffers. But everything else is much low level. And yeah, so does that mean that now we are going to have proprietary cameras? Not at all. It's exactly the same proposition and it's DRM. So in order for a driver to be upstream, there has to be an open source implementation complete, going from the driver up to user space. And these implementations needs to support basic stuff. It needs to support some features. You need to be able to do video conferencing. You need to be able to take single shot. And the image quality needs to follow some standards. And that has to be completely open. That means normal users will be able to use video conferencing and things like that, or your standard Linux application cheese. And that is what we want to use in Chrome OS. So in Chrome OS, we plan to use the complete open source stack. So we are going to make sure that vendors comply and do this. But that doesn't mean that vendors can also provide a secondary stack where they can do fancy stuff, like they can do whatever they want. It's free for them. Like, think of this like in the NVIDIA, more than NVIDIA, the AMD proprietary GPU stack versus the open source one. So the open source is what I install in my Debian. But if somebody wants to do gaming, they can install the AMD proprietary thing, and AMD can still sell their expensive hardware for gaming, and I can still use my camera, my hardware complete open source for my own purposes. So we don't want to stay in the middle of the industry. We want to work with the industry for a common goal. So challenges. This is the fun part. Okay, now we enter the territory with this is therapy for me more than a presentation. So when we came to the media people, they were not very excited about this. And the main reason they were not very excited was that they want that all the cameras, every single thing in the camera is completely described, which is something that is very difficult to achieve with vendors. Something we have tried and we have failed, and yeah. But according to them, everything needs to be open. So quoting them, a fully open source upstream driver requires opening the hardware access and documenting the APIs. However, enough information must be available so an open source implementation can be made. So it's pretty big a statement, and that has very strong consequences. So for one thing, what is going to happen, or what we are seeing happening, is that vendors, they are providing worse hardware for Linux than for other devices. They have the full set of hardware, and they chop it down, they remove features so they can comply. But this is not the worst. I mean, they can do this when hardware looks like blocks. But remember when I told you that hardware doesn't look like black boxes anymore. Hardware now looks like programmable devices. So what happens is that we are forcing our vendors to have we have an extra CPU inside their camera with a firmware that is exposing what Video for Linux expects. And this is bad. I mean, I don't know how many people have been exposed to vendor drivers, and yeah, it's tough to watch. Having software produced by vendors with absolutely no review, like zero review because it's firmware, with DMA access to hardware, I don't see that. How can that be better than a solution where that we are proposing? And that is what vendors are. That's what we are pushing vendors into. But can get worse than that. Some vendors have decided not to have their hardware in Linux anymore. So there are some devices with absolutely zero support for Linux. And when you ask them, they say, yeah, if users want to use Linux, they just have to get a USB camera. But I don't want to have an extra USB camera with my notebook. But this is, yeah, this is where we are pushing vendors. And yeah, sometimes it can even worse than that, which is that we only get downstream drivers. So right now there are some vendors that they provide you with a complete closed source stack. If it looks like the Android slide, it's because it's exactly the same as the Android slide. We are forcing vendors to go into that kind of engineering, and in my opinion, that's worse than having an open source solution. So, what is the secret agenda of Chrome OS? Since this is not recorded, I think I can talk about it, and we are all friends. So, there was initial discussions of Kcam, Video for Linux still is aging, and we need to do something about it. And that was in 2018. Google triggered or supported those discussions. And as a result of that, in 2012, we decided to start a reduced version of the initial approach, what we call Kcam Diet. Yeah, we started implementing it, and in June 2012, we make the public announcement of Kcam in kernel recipes. The code is available. You can download where we are. And in September, that's when we had the meeting with the media people, and where they said they don't like this too much. And where we are now. So what we are now is we are working on proof of concept using IPU6. IPU6 is the Intel camera. Is one of the Intel cameras. Maybe you know it because there was a very nasty article in LWN about the state of IPU6. So we are working in trying to fix that, and people can finally use their IPU6 hardware in an open way, or a more open way. And that's now where we are working, and we still want to push it upstream. We want to push it in the media subsystem or in other subsystems, or having our own subsystem if there's enough interest. We know the industry is on board. This is a solution. This is a compromise that they agree on, and I hope the community can also see the value. And there was no Rust in my presentation, but there's a small crustacean there. Yeah, and yeah, by the way, Kcam is not me, or not only me. There's a group of people that are working very hard, and they are much more clever than me, and working on this project. So thank you very much. Questions?
Okay, so you mentioned libcamera briefly, but is Kcam or is libcamera gonna use Kcam, or is Kcam gonna use like some different user space component?
So anything can be used as HAL. So in all the time we are mentioning something in user space that it's a HAL, right? I really want that to be libcamera. So for standard Linux distros and Chrome OS, I really want that to be libcamera. So if you see into this diagram, I really want it to be libcamera. So basically, we just want to replace the bottom with these video for Linux drivers, Kcam drivers. But maybe in Android, vendors, they will have different HALs. The reason is they want to compete, right? While libcamera, it provides you a standard API, but in Android, vendors want to compete, and they want to provide more features, and automatic makeup or background removal. It's things that libcamera is not looking into, but vendors see a big value on that.
Okay, so what was I gonna say? One moment.
Fine. Beer is waiting. No pressure.
Okay, right. So is there something you're in talks to, like with the libcamera people?
Yes. So
okay.
Google is working quite in good collaboration with them, especially in Chrome OS.
Okay, great. Yeah, that's just my concern, but that's great to hear then.
Thank you.
You want the cube?
Now you mentioned the IPU6 as a poster boy of it's hard to get information. I have the problem with IPU4, for example, on Apollo Lake. Do you think there's any hints? Because, for example, the CNDA with Intel, that's 5 years, then it's out of NDA. Do you think we can push them to, when it's 5 years old at least, that they push out the things usually on the CNDA so we can get access to them?
I cannot talk on behalf of Intel, obviously. What I can say is that IPU3 is still supported by Intel. So I think, so the good thing from Kcam is there's very little to be done in this. This is new and I cannot get used to it. It has 3 buttons, way too much for me. So it's very little commitment in this area. So maybe we can, it's a small investment. Maybe something like Kcam can open the industry for them. So one of the areas Video for Linux completely ignores is industrial imaging. And with Kcam, you can really do things like industrial imaging. So my previous life, I did quite of industrial imaging and things like multi-stereo imaging, special formats, 2 types of focus, big focus and a small focus. That's something you cannot do with Video for Linux, but with Kcam is very, very easy to do. So yes, I will think that if Intel see value in Kcam to enter new markets, I don't see any reason why they wouldn't do it, especially with a very small investment. But I cannot talk on behalf of them, obviously.
Of course.
So I have a technical question first. You showed that the user space can submit this task graph, right?
Which one? This one?
No,
Or-
in what you propose, you submit a task graph, right? Or a function
This one?
graph? Yeah, the graph of operations, sorry.
Yeah.
But how is I mean, I perceive this, and that's what I need to understand. So there is the graph of the operations that need to be run, and then you have the resources below, right?
Mhm.
The graph of resources. So the graph of resources, is it exposed by the driver, or?
Yeah. So drivers expose, they basically has only to implement two things. One is execute. That's when they execute an operation. And the other thing they do is signal. So whenever all the operations are in a queue, and they are built in a tree. Whenever an operation doesn't have any dependency, is sent to this, we call the execute from that specific device, for that specific entity.
And then it's up to the driver and the hardware to understand what type of operation needs to run on what type of underlying resource.
Yes, that's some hardware specific.
Okay.
Some hardware, they are multi-threaded, and in those multi-threaded, what you have is multiple instances of the same entity. There's some hardware which it looks like it has infinite amount of infinite amount of operations. Think of that like a JPEG encoder. Then what you do is you create instances on demand, and then there's the single threaded where you only have one instance per entity.
Okay. And the second question I have is a little bit more on the political side. So you mentioned that you want to enforce the vendors to always open source part of this. Can you elaborate a little bit more? Is it upstreaming to the Chromium OS, or?
So
Where would
there's
that be?
two things. One is that there's a letter of intent signed by Google explaining what our commitments. This is what we want. This is what we want open. This is what we allow to not be open. But that's just a piece of paper. The real enforcement is in upstream Linux. There's never going to be a driver accepted upstream unless there's a complete open source user space with a set of functionality that is defined. So can I use video conferencing? Yes. Can I take a photo? Yes. The photo doesn't look like shit? Yes. Then that hardware that driver is going to be accepted. Otherwise, the driver doesn't go upstream. And yeah, vendors, they can have their downstream drivers, but they can do that today.
Mm. But so the user space side, I mean, is it something that you would get on the Chromium OS, or? Or you would just need the GitHub link, for example.
Sorry. So in what we want is, I think libcamera is the perfect candidate for this. We think of this like Mesa, but we don't want to enforce vendors to use libcamera. If they want to provide a complete open source, they can do it. But why will they do it when there's already an open source thing that works and is going to take them 90% to their goal? But we don't want to enforce that. Again, this is a compromise. We want to be as open and support as much hardware as possible.
Thanks. Oh.
Anyway, so 4K USB cameras today, they use some kind of compression algorithm to be able to send 4K over USB.
Yeah, for it
Will
depends.
this actually be solved by this in any way? Do you think?
So there's UVC,
Yeah.
and I don't think
UVC doesn't handle 4K.
it doesn't handle 4K. yes and no. I mean, it works in USB 3.0. You could have 4K.
Yeah, but they do some kind of compression that's not part of the standard.
Yeah, but you can. That's why you have USB XUs, USB extension units.
Okay, yeah, but so it's not supported. That's my problem today.
Do you have a specific device in mind?
Maybe.
Okay, we can talk. There's asynchronous versus bulk transfers. That's one thing. Then the number of formats is limited in UVC, but there are ways around it, and yeah, we can talk. Yeah. Okay. Oh, nice. People are waiting. They want to get drunk. Come on.
Could you explain the part where you force vendors somehow? Is it when they if they want to make a camera that's used in a product that uses the Linux kernel, or?
Yes, when they want to upstream their driver.
Okay.
So when they send so there's a lot of benefits for upstreaming their driver. They don't have to maintain it through different versions. They don't have to maintain their own BSP. So when they want to upstream their driver, the driver cannot be upstreamed unless they fulfill the conditions.
Okay, so that's the carrot for them, so to say.
Yes.
Like the benefit.
I know. Do you prefer to throw there or there? He was first, but.
So what is the carrot for the vendor to upstream? Like, I know previously that the Chromium team was trying to nudge vendors towards upstreaming, but you're right now in your talk, you only mention like upstreaming, okay, that will be the criteria, but is actually in the part of bringing, of course, there's pressure to bring a product out in the market, and everyone wants to be fast and provide AI-enhanced pictures or whatever that means. So is there any enforcement on the political side planned on the Google side, or are you doing that?
So
currently when you're developing Chromebooks on the driver side and support package side?
Let me try to think what can I say, what cannot say. Stop the cameras. We're all friends. So yeah, so when vendors decide to produce Chromebooks, there's a set of requirements they have to comply, and Google trying to enforce upstream first, and that is what Google is doing. And there's also other decisions in the table when some hardware needs to be enabled. But for a vendor to upstream, all the pressure is not only coming from Google. I think we have done in the past, and we are doing a lot of pressure in that direction. If you look at the drivers into the media subsystem today, most of I don't have the number, but a lot of them have been because they have to be they wanted to be in a Chromium in a Chromebook. But a big benefit of things to be upstream is they can use it in distros. So you have a Debian, that device can run Debian, that device can run. I cannot think of any other distribution but Debian, and any other relevant one. So you don't have to work with 3, 4, 5, 7, 10 different distros in order to get your hardware supported.
Okay.
So I think the carrot is quite big.
So, given that Mauro managed to really piss off Linus recently so that he's not taking any media patches for a while, what's your plan to even get this upstream, or are you just going to take over and maintain it more sanely?
I think that's so that's a different problem, right? And I think Mauro has done a very good work in the past in being a maintainer, and I'm pretty sure I think so. The way the Linux works in general, the way maintainers work, I think in general that is what is. I think it's a good example of how maintainership in the kernel is something that doesn't scale up very well. So I don't think I don't think that's related to Kcam. And yeah. So if I can say something about Rust.
Well, it's related to you getting that upstream, or do you plan to make it? It did not sound like you plan to maintain this as a new top-level subsystem, but maybe I misunderstood this.
So I think the question you have to ask yourself when you want to have it as a new subsystem is why?
Yeah.
And right now there are things that are similar to Kcam that are not their own subsystem. So just to mention two is Video for Linux, and then the DRM subsystem. So we are working into political discussions with them, see if it could fit in any of their subsystems, and if that is not the case, we need to ask ourselves if a new subsystem is the new is the way forward.
Yeah. And the other totally unrelated question that really will want to make everyone drink beer: when are you, the Chrome OS team, going to take over Android to make it not suck?
No. I'm not by. So I think Android is an amazing product, to be honest. I'm not kidding. It has, thanks to Android, there's Linux has grown a lot in the past, and I think they are doing a lot of work to get up to speed into proper Linux, but it's a huge task. And I mean, I'm suffering because I have to work with a lot of vendors, but the amount of vendors I work is a tiny fraction that the number of vendors they are working with. So I think they are doing a very good job. I prefer Chrome OS much better, but that's because I work there, not because it's better. It's necessarily better. Thank you so much.